What's up, everybody? I'm Ned Bellavance, and welcome to a special sponsored video about the future of observability. A few weeks ago, I attended KubeCon in Atlanta, and while the focus was on Kubernetes, like the name implies, there was a lot of buzz and activity around observability. The Day Zero Observability Day event seemed to be the best attended of the pre-conference activities, with 2 separate tracks and rooms. There were dozens of talks about observability-related topics, and the expo floor had a large concentration of vendors specifically aimed at observability. I guess that shouldn't be a surprise. As applications have become more complicated and multi-tier, trying to monitor and track their status has also become more complicated. Simply firing up Nagios and setting some thresholds is not nearly enough. You need tracing, correlation, fault detection, and application integration. The explosion of AI on the scene only makes this whole thing more fraught. But at the same time, it also might solve some of the problems. To dig deeper into the world of observability, I sat down with Drew Flowers and Jacob Yakenovich from IBM Instana Observability. We talked about the challenges of application performance monitoring, how AI is changing what observability means, and what Instana is doing to embrace AI while keeping humans in the loop. We're here to talk about observability, and I can clearly see the two of you, so
and we can see you.
We're already ahead of the game.
We're already observing everything.
I want to start with you, Drew, and kind of find out how you got into observability in the first place, because it's not something you go to school for and you're like, when I get older, I want to be an observationalist.
I want to hang out with charts and graphs all day long. Really, it boils down to, I spent 17 years in various data center jobs, engineering at first, architecture. And in the last job that I had, when I joined the company, their monitoring mission was in what you would call a bit of a state. We had just a basic SolarWinds operation, but it was designed as a private cloud. So we were delivering SaaS operations to utility companies, but simply monitoring these data centers mostly from a purely hardware standpoint. What is my ESX host telling me? What is my VM telling me? What is my network, my storage telling me?
Sure.
But the problem is that fundamentally when you're delivering a software as a service platform, it really isn't the hardware that truly matters at the end of the day. It's the application. How is that behaving? How is that interacting with the customers? And that was a complete gap in our operation.
Okay, so you could see something's wrong with this host maybe, or this VM is X amount utilized, but that didn't mean anything from an application standpoint. You couldn't connect the two dots.
It didn't mean anything when a customer calls me and says, I'm trying to run this report against my metering system, and it's not responding.
Okay.
So that was the fundamental problem we had to solve at first. And the only way to really do that is through a more application-centric approach.
Right.
Which we didn't have.
Okay.
So, of course, me being the squeaky wheel in the room that says this isn't working, what do you think happens? You speak up, now it's your problem.
It's your job now, yep.
So I got assigned the task of how do we fix this? And at least when it came to Instana and observability, that's where my journey with this company truly began. I had a POC for every tool you can imagine, from AppDynamics to New Relic to Datadog to Dynatrace. And what we were discovering was that either the product incurred too much on our developer team to be able to implement, or if it was automatic, like say Dynatrace is, it was just too expensive for us to justify because we weren't the largest operation under the sun.
Right.
And that's how I wound up through an advertisement, believe it or not, on Reddit.
Those actually work?
Of this little robot that said, let's stand, solve all your problems, automatic application monitoring, and at my wit's end, I took a demo call. And as I sat there and listened to the pitch, I saw a lot of things that it just made sense. It clicked. What they were trying to pitch me didn't seem to have any marketing fluff to it.
Okay. I want to back up to something you said about the different potential observability tools that were out there. And in my experience, one of the main things a lot of them asked you to do was have your developers go and update their code in some way to add additional instrumentation so this service, whatever it was, could collect that information and make those correlations. Is that kind of what you were indicating? Was an issue with some of the products you looked at?
Oh, absolutely. I mean, at the time there was a little bit of development towards automation. There were only a couple of companies. At this point, it was more of your Instana and your Dynatrace were the only two that I could find. But one is very cost prohibitive because they're on the bleeding edge. But when you looked at the other products, they were still reliant on a lot of manual instrumentation. They may provide you some libraries, but those libraries had to be injected into the code.
Right.
On top of that, anything that you were doing custom, now you're talking about entry and exit spans, by hand instrumentation, and our development staff just said this was too much. We need to focus on building product.
Right.
So it was unviable in our architecture. And then you take the complication of Kubernetes and Docker, where now it's not just about the manual instrumentation. It's also about the fact that you have all of these native agents that are designed per language. And because of that, now you're talking about, I need to put the Java agent in the Java container, the .NET agent in the .NET container, on and on and on.
I see. You're more of a polyglot situation. You have all these different code bases, all that need to be instrumented slightly differently. That's going to be really difficult for your development team to manage. And if you're bringing in stuff from other development teams or outside, that's not going to be instrumented at all.
I mean, even abstracted from the development team, as the operations guy, guess who has to manage all those agents in each individual container?
Well, you did raise your hand. Okay, so that all makes sense to me, your journey, how you got from there to here today. I personally don't know a lot about Instana, and my assumption when I started doing some reading was you're going to need to add some stuff to the software or install an agent on every machine or something along those lines. But let me back up and ask you, what was involved in actually getting Instana up and running in that POC?
So that's the funny thing. If you go around our LinkedIn, and I think it might even be on our YouTube, shortly after the acquisition, I made a video that literally said, how long does it take to install Instana? Because we get this question all the time.
Right.
You guys advertise on ease of use. You advertise on automation. How automatic is this thing? There's a video out there that shows me end-to-end doing the whole thing in 1 minute and 27 seconds.
Okay, so that's pretty fast. What are you doing in that roughly 90 seconds?
Copy and pasting a curl command and getting a drink.
And it's the drink that takes the longest.
Exactly, because I'm just wasting time while I'm letting the script do its thing. And
Okay.
that's really the nature of it. You're talking about an architectural change, where before, what we refer to as a sensor, which is a component of our agent, it's an automatically deployed thing. And we chose the term sensor very explicitly, because when you talk about language agents, that denotes manual effort. You need to put this agent in place. A sensor, by definition, is a bespoke piece of technology that is designed to autonomously complete a job.
Okay.
So in our structure, you have the agent framework that exists in Kubernetes as a daemon set or a process and a host. And as that agent is running scans of the host, it's looking at process trees, it's looking at the file system, it's identifying what is actively running on this system. As it identifies these technologies, it's dynamically deploying these sensors that attach to each process individually.
Oh, okay.
So the automation is taking that former manual labor that you used to have to do, and it's eliminating it through automation.
Okay, and it's a custom agent for each type of process. So
No.
this one's running a JVM, this one's, or is it a different sensor? It's the
The
same sensor
has
configured
its own
differently.
thing. So you have
Okay.
the agent, and then say in the example you use, you have a Java system. It's a zero-touch implementation for Java tracing. And this is what blew my mind, because our old app stack in my last job was not a microservice architecture. It was an app box with
monolith.
37 JVMs and then a database server.
Right.
Very typical of the time. But because of the nature of the automation, there are two APIs under Java that it uses, JDK attach and JDK instrument. Because of that, the sensor is able to hook the JVM, grab the metrics, interact with the byte stream, inject the instrumentation, and it was doing this without requiring me to restart the JVM. That was the moment I became sold, because when I installed this on my app box, within 2-3 minutes, my dashboards are now populating with traces from all 37 Java services, completely automatically with zero effort from myself.
I want to go back to where we were in the deployment process. So I have this curl command, it's setting up an agent, and then that agent is deploying sensors based off of processes. What happens then?
Sensors report data back to the agent. The agent is more or less a perpetual Kafka stream to the back end. So when you think about agents, One of the major problems in observability especially is that they're intense against the operation of the VM. They require more resources. They require especially more RAM.
Yes.
This is a byproduct of effectively agents that spool data in memory and then fire it off in a bulk.
Okay.
We switch this around to be a Kafka stream. And within our laboratory test environments, the way that this works is that when a sensor reports data back to the agent, the time it takes from the agent to reach the backend in ideal network conditions and visualize that information is usually about 3 seconds.
Okay.
So not only are you getting much faster telemetry than you typically would in a standard bulk send environment, but the flexibility that it provides allows our agent to be extremely lightweight while collecting 100% of every trace. We do not sample it at the agent or the backend level, and we collect metrics every single second, so it's near real time without significantly impacting the host.
Okay. And what do you get at the end? So I've instrumented it. I've deployed the agent. I got the sensors. It's streaming the stuff to the back end. What am I seeing? How is it all getting connected together to give me observability into my applications and environment?
Well, that automation that I talk about is not purely about taking away the manual effort that's required to deploy things. There is actually a piece of technology under the hood that is core to our data model, and we call it the dynamic graph.
Okay.
The idea is that the agents and their automation, yes, they're helping you day to day deal with the maintenance of the tool, but because they're running that discovery in perpetuity, every single change that occurs in the environment is reported to our backend. And in real time, the backend is dynamically mapping everything. It's not just about application dependency maps and how this service connects to that service. It's about underneath that, the host and agents installed on top of, the containers that are operating on the host, the process in the container, the technology in the process, the service the technology serves out, and the endpoints that are being served by the service. So Instana has in perpetuity a real-time map of the entire environment from the infrastructure to the edge.
Okay.
And that's really the key. When you take that sort of mapping, it allows us to apply artificial intelligence and machine learning in a variety of ways for root cause analytics. But it also gives us the capability of dynamically filtering dashboards that we provide to you out of the box. Because from an observability standpoint, a lot of vendors very much focus on custom dashboards. Datadog, for example, beautiful dashboards, right? But guess what? You got to set all that up yourself.
Right.
And you have to maintain that yourself. Say you go in and you change a namespace or a pod name, that can break your entire dashboard. Within Instana, we actually flip this around. We still allow customization, but we ask organizations, where does that customization make sense? And instead, we want you to consume telemetry data. So everything from end user monitoring to infrastructure to application dependency maps and API mapping is provided completely out of the box. And this is one of the core differences between us and a lot of the other products in the space, is that we can genuinely begin solving problems within the first 10 minutes of an agent installation, because these dashboards are auto-populated, they're delivered to you. And it's a consumption philosophy. Consume telemetry, don't build it. So within our systems, we're applying everything from base machine learning statistical models to agentic AI, to causal AI, to generative AI, all the way down through the stack. But when we're applying these against our data, we're trying to answer a question that honestly I don't feel enough both customers and other organizations providing these services are asking. Where is the value? Oftentimes, there's this race to just simply say, we have AI. But no one is standing back and saying, what is this really doing for me on a day-to-day basis? How is this changing my life?
Right. Jacob, you and I were talking about that earlier before we had a chance to start filming, about finding the value of AI, because this happened in haste.
Yes.
The AI boom happened, ChatGPT happened, and suddenly every company executive was demanding, well, we need to add AI to our products immediately. and so we did. And now it's like, okay, we spent a lot of money on that project. Was any of it worth it?
It's important to find out if the AI juice is worth the squeeze. And what we're seeing are predominantly 3 primary approaches to using agentic large language models or generally useful artificial intelligence into the context of an application. So the first is what we call an add-on style.
Okay.
Where you got an application today and you want to add a chat experience to your conversation or your application. At the end of it, the user who's using that application can just perform the regular workload of the given application. If they use the chat experience, great, it's an add-on.
Okay.
But they can continue to function and provide the value that the company's trying to deliver with as normally.
Yeah,
as we see as an
whipped
add-on
cream
style.
on top of your ice cream. It's great
Eat
if it's
it,
there.
great. If it's not
but
there,
if not,
fine.
Little cherry.
Yeah.
It's fine.
No big deal. That's an add-on style. The next predominant approach that we see our customers use is another one called a blocking style. Now, this
Okay.
one's a little different. This is where, as part of the overall application workflow, I am injecting a agent-based or large language model solution into the work stream of the given application or service. Think of like a clearinghouse for checking to see if there's fraudulent activity for a given transaction of an application.
Right,
Well,
okay.
now you cannot complete the application workflow without going through a large language model or agentic-based solution to do so.
Right,
So
right.
if you see that particular, what is effectively a microservice that is generating content start to hallucinate, bias, be erroneous in the content that it's generating, now you're interrupting the overall workflow of the overall application. So it's not about latency, error rate, performance, or throughput anymore as one of the initial sets of golden signals. Now it's about wrong. If the large language model or the agents that are producing that content are wrong, that is a new golden signal, the new representation of being down.
Right.
Because if you're looking to see, for example, let's just make a hypothetical example. You want to book a flight from, say, London to Madrid. And as part of that response, you see a recipe for pineapple chocolate chip cookies as the response to that, right? It might sound interesting to taste, but that's not, regardless, that's not why a particular user went to that application. They wanted to buy a flight.
Right.
So if that particular system is now generating content that is erroneous or faulty in some way, it is wrong, and the user, what are you going to do if a flight reservation system gives you a recipe for a weird tasting food? You're going to probably
go to a
not
different
book it,
site.
maybe even go to a
Yeah.
different company.
So maybe if I need weird recipes, I'll come back. But just
Exactly.
generally speaking,
I'm going to go someplace else to book my
yeah,
flight.
I'm done. So,
Exactly. So understanding we have a brand new technology that is involved in the overall application, understanding what's going on, what's being generated, what are the prompts, what are the evaluations of those prompts, is a new era of observability to understand as users are taking advantage of those applications, what's going on inside that and at that particular point of view. Mm-hmm. The third area is another one that's more of an emerging characteristic where the application is an agent and then agent is an application and there's no discerning differentiation whatsoever. That's more of a 4 or 5-ish year timeline, but so we're seeing a predominant, the first two characteristics, either as an add-on style
Right.
or as a blocking style from the uses of artificial intelligence in our customers' applications.
Yeah, especially in that initial rush, it was
Yes.
easy to bolt on a chatbot, which is like what everybody
Exactly.
did, and everybody hated the new chatbot. Not all the time.
Yes.
So there was one time that I was trying to do something on a website, and the chatbot was like, "Ooh, can I help you?" And I was like, "Actually, you might be able to." And I was like, "How do I return this item?" And it was like, "Oh, here's our page for returning the item." I was
Yeah.
like, a chatbot was helpful? Stop the presses. Run an ad.
I love the new AI revolution. All right.
You showed me the returns. But I mean, generally speaking, that was not great. But the second use case takes a little longer to implement, but makes a lot of sense.
It does.
Especially if you're doing fraud detection or something else that requires a little more context and processing. But yeah, if it's wrong, and it's being consistently wrong, that means your application is down.
Correct.
Exactly.
Correct. And it's not the way to grab that and understand that from the perspective of the application is not through traditional metrics, events, logs, and telemetry data. It's getting into what's being generated inside the agent or inside the large language model, understanding what's being prompted in there, what are the evaluations coming back, and understanding exactly what's happening inside those assessments. The problem that we're seeing now is it's great to provide that information, but if you've got millions of application transactions on a given day, that's dozens of millions of prompts and responses, and human beings can't look through all of those.
Right.
You might be able to peck at some of them, but in aggregate, you need a computer.
Are you
to
saying
help
the
figure that
solution
out.
to my AI problem is AI?
A set of analytics. Let's go that way.
Fair. So that's for monitoring the AI that other folks are using.
Correct.
Are you also leveraging AI more in the existing product to assist SREs?
Yes. One of the things that we found often with Instana is it is so comprehensive in the representation of what is going on and why systems are behaving the way they're behaving. When operators, site reliability engineers, developers, IT operations teams, executives want to understand what's going on and why, that can be a little overwhelming in terms of understanding exactly the answer to that question. And when thousands of dollars per minute are on the line, you need to answer that question as definitively as you possibly can with the highest degree of confidence behind it.
Right.
So what we've done is to find a set of algorithms and analytics, including artificial intelligence and generative AI and several different large language models in an agentic-based solution. So this isn't just one ring to rule them all. This is the right type of analytic for the right type of data for the right purpose and outcome that we're trying to accomplish, is to look through all of our insight and then showcase here. Here is something that doesn't smell right. Here is an issue, or here is an incident that Instana has detected based on its analysis of metrics, events, log data, or telemetry data, or a combination of any of them, and then showcase to us as people, here's where you need to pay attention. Here's the evidence that I've found and gathered. Here's the probable cause of the issue that I've identified. Here's the explainability. Here is the reasoning. Hit a button to summarize it so that you can see it in plain English. And then once you're agreeing with that particular hypothesis, here are the suggested actions to take. And by the way, if you need help, or if you want to say, for example, I kind of agree with the initial hypothesis, but I want to ask some more questions, then it makes sense to introduce a dialogue where you can interact with Instana through chat experiences as well. Let me continue the conversation from the preliminary hypothesis. That's a differentiator, in my opinion, because there's a couple of competitors out there that think that you should just sit in front of a dialog box in an open text and say, do I have a problem, ? Yes, you have a problem. That's a toy. You don't have time for toys in operations. You're working on tools to be able to solve what's going on, because seconds matter. So this is more to continue the conversation with Instana's data set in English and decide whether or not you agree with that preliminary hypothesis that's being formed by asking several follow-on questions. But we're giving you our homework first, and then allowing you from there to ask additional probing questions. And then once you're finally in agreement with it, the last but certainly not least thing that we do is, here's the set of actions that we suggest that you do. Sometimes there aren't any. And in those circumstances, especially if it's early hours or off-duty time when you're an operator or in site reliability engineering, you're trying to figure out what action to take, or I might remember what to do, but not exactly the particular sequence or steps to do, we have another layer of artificial intelligence there to say, help me generate a action, either be it a knowledge base article or a Python script or an Ansible playbook, so that I can take the context of the incident, put it into a knowledge base article, or take those individual knowledge base article steps and turn them into Ansible playbooks or Python scripts, where as an expert, I'm utilizing the technology that says, yes, correct, I can look through the sequence of the steps that Instana is helping me generate. As the expert, I see exactly that. I wouldn't have remembered it during off-duty hours or 3 o'clock in the morning. Sleep inertia is a very real thing. To be able to go from sleeping state to waking state is about 20-some minutes. So, right?
If you're lucky.
If you're lucky, depending on how you went to sleep the night before. But the idea is, I'm going to help you accelerate and look at that information and say, yes, I see exactly the steps that I wouldn't have remembered to do in that particular sequence, but I can take my args, parms, and keys that I know, put them into what the script was generated, and my confidence is higher that what we're about to go do is going to rectify the situation, because as the expert, this helped me figure out exactly the steps I needed to take to rectify the situation as quickly as possible.
So it's very much a human is still in the loop.
Absolutely.
As part of the whole process.
Much akin to the way a mathematician uses a calculator. This is going to help you accelerate the math that you're trying to come up with. But in this case, the math is the operational state of a very sophisticated environment that's your business.
And it's also touching on something that, honestly, being somebody who's out in the field interacting with our customers pretty much every day, it touches on a real concern that especially SREs have. When you bring AI into the conversation, oftentimes you get the question of, is this thing designed to replace me?
Right.
There's a certain level of trust that has to be built into an AI system. And One of the aspects that I think we've really done from, in my opinion, just more of an ethical standpoint is, as Jacob said, we're very adamant about keeping the human in the loop. These are not systems that are designed to replace a human being. They're designed to amplify their ability to solve problems, whether that's through automatic generation of scripts or pointing them in the right direction faster. And when you look around the space, especially when you talk to various business leaders, that's not a philosophy that's necessarily shared across the board. But when you're trying to engage an engineering team, when you're trying to get them on board with your philosophy behind observability, that's really the key. They want to know that this thing is not going to put them out of a job. And realistically, we shouldn't be putting human beings out of the job, because these systems, depending on which research you look at, even now with the latest models, you're looking at anywhere between 3 to 37% of hallucinations being generated.
Right.
So these systems, no matter how good they're getting, they're still not 100% trustworthy. And that requires that human being to validate the data. And for us, that's a big reason why I'm very proud of the fact that anything we do with AI, like if you hit the investigate for me button with our agentic systems, it doesn't just tell you, here's the problem. It says, here's the problem, and here is exactly how I came to this conclusion.
Exactly.
It's about transparency.
Yes.
And by creating that transparency, we have a much easier time coming to market with our customers and building trust, because they see the reasoning, they see the factuality, they see that it's not inherently designed to put them out of a job, and that helps us accelerate our trust-building exercise with these companies.
And as part of that, trust extends into an understanding of explainability and details in our user experience so that people know whether or not they're looking at fact that's coming from the observed environment or whether or not it was generated content from our analytics. So throughout our experience, when there are generative AI capabilities, it shows this is generated by generative AI. Or when we talk about that we've identified probable root cause, probable being the key word there. We don't know for sure. We're not going to get ahead of our skis. We want a human being to verify this is an initial hypothesis, but here's all the reasoning and explainability, as Drew mentioned, to help the user get to the conclusion. I mean, sure, if you want to sift through the entire data set that's throughout Instana, go ahead. But we're saying this is a rapid accelerant to being able to get to that initial hypothesis. And if you agree with it, take the next steps so much faster than it would be to try to diagnose and get everybody in the war room and point sideways at everybody else. Understand, not my problem, somebody else's, and get to that central understanding of what's happening and why.
The key word is transparency.
Yes.
To me. Being able to know where it got this information from, why it made up this line of reasoning, and you being able to investigate. But because ultimately, at the end of the day, if the system is down, if the application is not responding, it doesn't matter if you or the Instana AI agent made the change. You're the one who gets blamed for it. You're the one on the hook and responsible for the health and the well-being of the system. You can't just blame it on AI and throw up your hands.
At the end of the day, it doesn't matter what automation tool you're using, there is still a human being that will be held accountable.
Automation is amazing, and AI can definitely help, but I love how Drew and Jacob stressed the importance of people as part of the solution. And speaking of people, big thanks to both Drew and Jacob for being excellent humans and taking the time out of their busy schedule to chat with me. Also, thanks to IBM for sponsoring this video. It's partnerships like this that allow me to keep producing quality content for you. And of course, thanks to you for watching and sharing your thoughts. If you enjoyed the video, please give it a like and a subscribe if you think I've earned it. Until next time, stay healthy, stay safe out there, and be kind to your fellow humans. Bye for now.